Hello calculus students, I wanted to finish off the example that we started off in class, and that is to find the area under the function f of x equals 5 minus x squared on the interval from 0 to 2. And we ended with that to find the actual area under the curve, we're going to use this limit. The limit as n approaches infinity of the summation from I equals 1 to n of f of c sub I times delta x, where c sub I are all of the x coordinates that we use to create our rectangles, and delta x is the width of each rectangle. I did talk about the formula for delta x in class today. That is delta x is equal to b minus a over n. Since our interval is from 0 to 2, that is going to be 2 minus 0 all over n. That simplifies to 2 over n. So 2 over n is going to be the expression we're going to use for delta x. C sub I, this formula I didn't talk about in class today. A plus delta xi, and I won't be able to explain it just now, but this is the formula that is going to help us find all of these x coordinates. In this case, the formula is a plus delta xi. A is 0 from up there, plus delta x, which we just found, is 2 over n times I. Let's simplify this, and this becomes just 2i over n, just multiplying the 2 with the I. Plugging that information back over here, it looks like this. Limit as it approaches infinity of the summation from I equals 1 to n of f of c sub I, which we found is 2i over n, times delta x, which we found is 2 over n. Since 2 is a constant and n we're considering the constant for the number of rectangles, I'm going to use the constant multiple rule and take this out right in front of the summation. That is going to be the limit, as n approaches infinity, of 2 over n times the summation from I equals 1 to n of f of 2i over n. Now you guys, we've done this many times. The function is up here, 5 minus x squared. We're plugging 2i over n into it, so that's going to become 5 minus 2i over n, the quantity squared. And the 2 over n is out here. So f of 2i over n becomes this. Simplifying in our next step a little bit, that is limit as n approaches infinity of 2 over n summation of 5 minus 4i squared over n squared. Now, we're going to continue on and distribute the summation to the 5 and to the 4i squared over n squared. That looks like this. Limit as n approaches infinity of 2 over n times the summation of 5 minus the summation of 4i squared over n squared. Let me include my I equals 1 to n. Next step. Since the 4 and the n squared are both considered constants, we're going to take them out of the first summation. That is the limit as n approaches infinity of 2 over n times a summation from I equals 1 to n of 5 minus 4 over n squared times the summation from I equals 1 to n of I squared. Took the 4 and the n squared out of the summation here. Now we have formulas to be able to do these two summations. The first one is just a summation of a constant. So that gives us 5 times n, 5n. Minus 4 over n squared times the summation of I squared, and hopefully you guys have that one memorized. That is n times n plus 1 times 2n plus 1 all over 6. N times n plus 1 times 2n plus 1 all over 6. Now what's interesting here is at this point this expression over here on the right involves only n's. So now we're just trying to write it into a form that we could find a limit. In order to do that, we have a little bit of algebra to do. And after we do that, we're going to be able to apply the limit. First, I am going to cancel an n here. This cancels and that cancels. And the 4 and the 6 reduce by 2, so that's going to be 2 and 3. After I've simplified, I'm going to take the 2 over n and distribute it here and here over there. 2 over n times 5n is just going to give us 10 minus 2 times 2 here is going to give us 4. N times, there's 1 n here and a 3, that's going to be 3n squared. So that's going to be 4 times n plus 1 times 2n plus 1 all over 3n squared. Now the n plus 1 times 2n plus 1, I'm going to go ahead and multiply. That gives me 2n squared plus 2n plus 1, sorry, that is times plus 3n plus 1. Hopefully, yeah, we're looking good so far. I'm going to go ahead and distribute that 4 into that. So that's going to be n, limit as n approaches infinity, of 10 minus 8n squared plus 12n plus 4 all over 3n squared. Finally, the limit as n approaches infinity of this, well, the 10, there's no n here, so that's just 10. And then this is that method that all of you guys enjoy doing, where you take the highest power of the denominator and divide everything by that, over n squared, over n squared, over n squared, over n squared. And after simplifying everything, this becomes 0, this becomes 0, and we're just left with 8 over 3. So moving over there, we have our limit comes out to be 10 minus 8 over 3. Hopefully you know your fractions. 30 over 3 minus 8 over 3, which is 22 over 3, or 7.3333, which we had calculated in class. With that, you found the area under the curve is 7.333. All done. Thank you.